Now let's look at this question D from paper 2012. In 1802, William Wollaston noted that the appearance of dark lines in the spectrum of sunlight. These lines are due to the presence of certain chemical elements in the gases surrounding the sun. Explain why sharp dark lines appear only at specific wavelengths. So it has something to do with the energy levels. It is about Bohr's atomic model. Bohr's atomic model can explain this. And we have this absorption spectrum and emission spectrum. Absorption spectrum looks like this. Now this is like the poor man version of it, okay? The short version of it. This is going to be the absorption spectrum, and this is going to be the emission spectrum. Now, if we're talking about the same element, the odd part of both spectrum should happen at the same place. Okay, now why? So the dark lines in the spectrum of sunlight, we're definitely talking about this one. Absorption spectrum. We know that the sunlight, when it is spent, it will give us the continuous spectrum of visible light from red to violet, continuous, without any gaps, without any like dark lines. Now, why here, we can see these dark lines? That is because we know that when certain light with a certain frequency shines on the gases, we don't know what gases is, okay? Gases. It is going to be absorbed by the electrons of this certain gas, of this certain element. So this kind of color is going to be absorbed by this gas, by this the electrons of this gas, so that we can see the dark lines. Then we can say something like this. We can say originally sunlight gives continuous spectrum of visible light. You can say from red to violet. When it shines on some elements, it shines with energy. If the energy is just the amount to make the electrons to jump to a higher energy level, then the light Also, actually, the color, the frequency, the color is absorbed by the electron. So we see dark lines. And you can refer to my absorption spectrum video to understand in detail why this happens.